So, you want to work with data in Python, right? Well, there's one library you absolutely cannot ignore. Today, we're going to break down the foundation of the entire data science ecosystem, NumPy. Let's jump right in.
Okay, let's kick things off with a problem I bet you've run into. You're trying to chew through a big data set, and your code just grinds to a halt. So what gives? The simple answer is that regular Python lists, as amazing as they are for so many things, just weren't built for the kind of heavy-duty number crunching that data analysis demands.
And this slide, it just nails the why perfectly. Over on the left, you've got your standard Python lists. They're super flexible, sure, but that flexibility makes them slow and total hogs when it comes to memory and speed for big math problems. But on the right, you see the solution, NumPy arrays. They're lightning fast, use way less memory, and are built for one thing, high-speed math. We're talking up to 50 times faster than a regular Python loop. No joke.
So what is this powerhouse? Well, it's NumPy, which, you guessed it, stands for numerical Python. Think of it as the core engine for any serious scientific computing or data analysis you're ever going to do in Python. It's what gives Python its number-crunching superpowers. Now, this is why learning NumPy is totally non-negotiable. I mean, just look at this list. Pandas, scikit-learn, TensorFlow, PyTorch. These are the heavy hitters, the biggest names in the data science world. And guess what? Every single one of them is built right on top of NumPy. So if you really get NumPy, you understand the bedrock of the entire ecosystem.
All right, enough theory. Let's get our hands dirty and actually dive into the core toolkit. And the first, most fundamental thing you need to know is the NumPy array itself. And you're going to love how simple this is. You literally just take a regular Python list and wrap it in the np.array function. As you can see here, we can make a one-dimensional array, think of it like a single row of numbers, and a two-dimensional array, which is basically a table, with rows and columns. Okay, so you've made an array. What's the very first thing you do? Seriously, almost every time. You check its shape with .shape. That output, 2, 2, just tells us we have 2 rows and 2 columns. Now this seems basic, but I promise you, understanding and managing array shapes is absolutely critical in machine learning. Mismatched dimensions are probably the #1 reason your code will crash.
Okay, so you've got your data locked inside this array. Now what? How do you actually pull out the specific bits you need? That's where indexing and slicing come in, and it's a skill you'll use constantly. All right, check this out. We've got a super simple array here to play with, just the numbers 10, 20, 30, 40, and 50. Now, what if you don't want the whole thing? What if you just want those numbers in the middle? By using this syntax, array14, we can grab a slice of that data. And this little trick right here, you'll be using this all the time. This is how you do feature selection for your machine learning models or clean up a messy data set. It's fundamental.
All right, now we get to the fun stuff, the magic behind NumPy, the stuff that makes it so blazing fast and powerful. And we're going to start with something called vectorized operations.
This is a total game changer. See, normally in Python, you'd have to write a clunky for loop to go through each number one by one. Super slow. With NumPy, you just take the whole array and say r times 2. That's it. NumPy then uses highly optimized, pre-compiled C code under the hood to perform that operation on every single element at once. That's how the pros do it. No loops, just pure speed.
Okay, next up is a concept that is insanely powerful. But, I gotta be honest, it trips a lot of people up at first. It's called broadcasting. And listen up, because this is a huge favorite in data science and machine learning interviews. So you really want to nail this one down.
So what on earth is it? Think of it like this. Broadcasting is just NumPy's clever way of letting you do math on arrays that don't have the same shape. In this example, we're adding a single number, 10, to a whole 2D array. Instead of throwing an error, NumPy is smart enough to stretch or broadcast that single number across the entire array, adding it to every single element. It's genius. It makes adjusting huge data sets incredibly simple.
And of course, what's data science without some stats, right? Well, NumPy has you covered. Finding the mean, the sum, standard deviation, the minimum or maximum values, it's all just one command. These are your bread and butter for what we call exploratory data analysis, or EDA for short. This is how you start to understand the story your data is trying to tell you.
All right, so we've looked at all these individual pieces, the building blocks. But how does it all fit together on an actual job? Let's walk through a real-world scenario to see how these skills come to life. And I really want to drive this point home. This isn't some abstract academic exercise. The technique we're about to cover, data analysts use this literally every single day to filter and make sense of their data.
And that technique is called Boolean indexing. It's a simple three-step dance. Step 1, you've got your data, right? Your array. Step 2, you create a condition. It's like asking a question. Hey, which of these numbers are bigger than 50? NumPy gives you back a new array of trues and falses. We call this a mask. And for the final step, you use that mask on your original array and boom, it spits out only the numbers that answered true to your question. It's like magic for filtering your data.
Okay, you've seen the core ideas, you've seen how they're used on the job, now it's your turn. It's time to stop watching and start doing. Welcome to your first NumPy challenge.
So here's your challenge. I seriously want you to pause this and give it a shot. First, create a NumPy array with all the numbers from 1 to 20. Next, use the reshape method to turn it into a 4x5 matrix. Then, use those slicing skills to pull out only the third column. And finally, calculate the mean of just that column. This little puzzle right here, it ties together pretty much everything we've talked about.
So, how'd it go? Hey, if you got through that, you've got a fantastic handle on the core operations that really power all of data science in Python. Mastering these NumPy skills is the absolute essential first step before you can move on to the bigger libraries. Which leaves us with just one question. Are you ready to tackle pandas next?